Good day, Acute Angels! Welcome to a new learning episode. I am Sir Joshua Santos, your teacher for Grade 8 Mathematics. Before we start today's lesson, kindly prepare your self-learning module, your pen and paper, to write your answer as we progress with our discussion. And most importantly, look for a place in your home where you feel safe and comfortable. You may also comment or ask questions at the comment section. In this learning episode, I will be guiding you in this week 4 lesson for the first quarter of Grade 8 Mathematics. At the end of this lesson, you are expected to perform operations on rational algebraic expressions. In the previous episode, you have learned about simplifying rational algebraic expressions. To simplify a rational algebraic expressions, factor both the numerator and denominator, and then divide the numerator and denominator by their common factor, or simply cancelled out. The simplified form of a rational algebraic expression is like the simplified form of a numerical fraction. The numerator and denominator have no common factor other than 1. So before we proceed with our topic, let us have a short review about the previous lesson. For the instruction, simplify the following rational algebraic expressions. Are you ready, grade 8? I think you are always ready. Let's start with number 1. Simplify 7x squared y raised to 5 over 28x raised to 4 y cubed. You have 10 seconds to answer. Go! You are correct. The answer is y squared over 4x squared. We get the factor of numerator and denominator. Then, divide the numerator and denominator by the common factor, or apply the cancellation rule. And then, we get the final answer, y squared over 4x squared. Next, for number 2, simplify x squared minus 1 over x squared plus 3x plus 2. You have 10 seconds to type in your answer. Go! Time's up! If your answer is x minus 1 over x plus 2, excellent! You got the correct answer. In getting the factor of this expression, you need to recall your lesson in factoring polynomials. The numerator is an example of factoring difference of two squares. That's why we get the factors x plus 1 and x minus 1. On the other hand, the denominator has factors x plus 1 and x plus 2. Next, cancel out the common factors, and we have x minus 1 over x plus 2. It seems that you are doing a good job with your lessons. And for last number, simplify 3x minus 6 over x squared plus 6x minus 16. Your timer starts now. Brilliant! The answer is 3 over x plus 8. Factor both the numerator and denominator and cancel out the common factors, which is x minus 2. And the result is 3 over x plus 8. Very good, grade 8 learners! With the excellent performance you did, I guess we are now ready to discover the next lesson. For today's lesson, I will be discussing to you the operations on rational algebraic expressions. When we say operations, there are 4 words that comes in our minds: addition, subtraction, multiplication, and division. We will discuss them one by one on how to perform them in rational algebraic expressions. In performing operations on rational algebraic expressions, we need to also consider your previous lesson in mathematics about operations on fraction, because rational algebraic expressions are written in fraction form. It is really a big help for you if you already knew how to perform operation in fraction. But don't worry, we will recall them as we proceed with our discussion. Our goal in this discussion is to learn and understand the key concepts on the operation on rational algebraic expressions. As this clear to you through the succeeding activities, remember, do not forget to think about how to apply these concepts in solving real-life problems. Without further ado, let us now perform operations on rational algebraic expressions. Let's start with multiplying rational algebraic expressions. The product of two rational algebraic expressions is the product of the numerator divided by the product of the denominators. In symbols, a over b times c over d is equal to ac over bd, where b times d is not equal to 0. The process of multiplying rational expressions is shortened by cancelling factors common to both numerator and denominator. Just like in your previous lessons about fractions, when you multiply two fractions, you just need to get the product of the numerators and the product of the denominators. For example, 2 over 9 multiplied to 3 over 14. When you multiply the numerators, 2 times 3, the answer is 6. And when you multiply the denominators, 9 times 14, the answer is 126. Now, lowest term the product to get its simplest form by getting their common factor, which is 6. So 6 divided by 6, we have 1. And 126 divided by 6, we have 21. And our simplest form is 1 over 21. We can also shorten the process of multiplying rational expressions by cancelling factors common to both numerator and denominator. In 2 over 9 times 3 over 14, 2 and 14 have a common factor of 2. So we can cancel 2 and it will become 1. And 14, dividing it by 2, and we have 7. On the other hand, 9 and 3 have also a common factor, and that is 3. If we cancel 9 by dividing it by 3, the answer is 3. And cancel 3, it will become 1. Now, multiply the numerators 1 and 1, we have 1. And the denominators 3 times 7, we have 21. Our final answer is 1 over 21. Same as the answer in the first method we use. We can also use this technique in multiplying rational algebraic expressions. Let's have examples to better understand the concept of it. For example number 1, find the product of 5t over 8 and 4 over 3t squared. You can use the methods we recall a while ago, but I can give you a step-by-step procedure in solving this. So just follow it carefully. For step number 1, express the numerator and denominator in factors. Here, we have 5 times t over 4 times 2 multiplied by 4 over 3 times t times t. Next, for step number 2, cancel out common factors. We can cancel t and 4. Now, proceed to last step. Simplify if needed. Multiply 5 and 1, and we have 5. And then in the denominator, 2 multiply by 3t. So we have 6t. Our final answer here is 5 over 6t. Did you get it? Very good, grade 8 learners. Let's have another example. Grab your pen and paper. Try to answer this on your own. Just follow the steps carefully. Are you ready? Here we go. Find the product of 3y plus 3 times y plus 4 over y squared plus 5y plus 4. I'll give you 10 seconds to answer it. Go! Don't forget, an expression which is not a fraction can be written in fraction form by using 1 as the denominator. Okay, time's up. Let's see if we get the same answer. Okay, first, express the numerator and denominators in factors. We can factor 3y plus 3 to 3 times the quantity of y plus 1 because they have a common factor of 3. After that, get the factors of a trinomial in the form ax squared plus bx plus c equals 0. So y squared plus 5y plus 4 has factors y plus 1 and y plus 4. Now, we can cancel out the common factors. So cancel y plus 1 and y plus 4. Then, simplify. Our answer is 3 over 1 or 3. Did you get the same answer? Very good, grade 8 learners. Now, let us proceed to another operations, which is division. In dividing rational algebraic expressions, the quotient of two rational algebraic expressions is the product of the dividend and the reciprocal of the divisor. In symbols, a over b divided by c over d equals a over b times d over c equals ad over bc, where b, c, and d are not equal to 0. Going back to your previous lessons about fractions, when you divide two fractions, you just need to get the reciprocal of the divisor and then multiply to the dividend. For example, 15 over 16 divided by 5 over 8. First, get the reciprocal of the divisor 5 over 8 and it will become 8 over 5. Then change the sign from divide to multiply. You can now multiply the two fractions following the steps in multiplying fractions. Get the common factors of numerators and denominators. In 15 over 16 times 8 over 5, 15 and 5 have common factor 5. So we can cancel 15 by dividing it by 5 and we have 3. And cancel 5, it will become 1. On the other hand, 16 and 8 have also common factor and that is 8. So if we cancel 16 by dividing it by 8, we have 2. And cancel 8, it will become 1. Now multiply the numerators, 3 times 1, we have 3. And the denominators, 2 times 1 equals 2. Our final answer now is 3 over 2 or 1 and 1/2. We can also apply this in dividing rational algebraic expressions. Let's have example to better understand the concept of it. For example number 1, find the quotient of 6 over 9c squared divided by 12 over 27c squared. I will also give you steps in dividing rational algebraic expression using the methods we used a while ago in dividing fractions. For step number 1, get the reciprocal of the divisor. So we have 27c squared over 12. And don't forget to change the sign into multiply. Then, get the common factors of numerators and denominators. 6 and 12 have a common factor of 6. So we can cancel 6 by dividing it by 6 and we have 1. Cancel 12 by dividing it by 6 and we have 2. Next, 9 and 27 have a common factor of 9. So we can cancel 9 by dividing it by 9 and we have 1. Cancel 27 by dividing it by 9 and we have 3. We can also cancel out c squared because they have a common factor. And for last step, multiply the remaining factors in the numerator and the denominator. So our final answer is 3 over 2 or 1 and 1/2. Are you following? Very good. Let's have another example. Try to answer this on your own. Just follow the steps carefully. Here we go. Find the quotient of n squared minus 25 over n squared plus 5n divided by n plus 5 over n. I'll give you 10 seconds to answer this. Go! Time's up. Let's see if you got it right. Following the steps in dividing rational algebraic expressions, First, get the reciprocal of the divisor. We have n over n plus 5 and change the sign into multiply. Then, get the common factors of numerators and denominators. N squared minus 25 is an example of difference of two squares, and it has factors n plus 5 and n minus 5. Next, we can factor n squared plus 5n to n multiplied to the quantity of n plus 5 because they have a common factor n. Now, we can cancel the common factors. So, cancel n plus 5 and n. Lastly, multiply the remaining factors in the numerators and denominators. And the answer is n minus 5 over n plus 5. Did you get the same answer? Very good, grade 8 learners. Always remember, in dividing rational algebraic expression, don't forget to get the reciprocal of the divisor and change the sign into multiply. After that, division has the same steps as multiplication in performing operation on rational algebraic expression. Multiplication and division are easier to solve, that's why we discuss them first. While the remaining two operations, addition and subtraction, have conditions that needs to be considered. Because rational numbers are classified as either similar or dissimilar. If they have the same denominators, they are said to be similar. If they have different denominators, they are dissimilar. We have a different approach or method in solving rational algebraic expression based on their denominators. Let's start with adding and subtracting similar rational algebraic expressions. In adding or subtracting similar rational algebraic expressions, add or subtract the numerators and write the answer in the numerator of the result over the common denominator. In symbols, a over b plus c over b is equal to a plus c over b, where b is not equal to 0. For example, in your previous lesson in adding or subtracting fractions, let's have 5 over 18 plus 4 over 18. Look at the denominator of the two. They are similar fractions. If the denominators are similar, we can apply this method. Just add the numerators, 5 plus 4 equals 9, and copy the common denominator, 18. And the answer is 9 over 18, or 1/2 if we get its lowest term. Now let's have an example in rational algebraic expression. For example number 1, determine the sum of 4 over x plus 10 over x. Check the denominator. And yes, they are similar. We can now simply add the numerators. 4 plus 10 equals 14. And copy the common denominator, x. And the sum is 14 over x. Did you find it simple? Very good. Let's have another example. Try to answer this on your own. Just follow the steps carefully. Here we go. Subtract 2x squared plus 12x plus 17 over x squared minus 25 minus x squared plus 2x minus 8 over x squared minus 25. Try to answer this in 10 seconds. Go! Time's up! Let's see if we get the same answer. First, observe the denominators. They are similar. Now, just simply combine like terms in the numerators. So don't forget the minus sign. It changes the signs in every terms of the numerator in the subtrahend. So x squared plus 2x minus 8 will become negative x squared minus 2x plus 8. So we have 2x squared minus x squared equals x squared. 12x minus 2x equals 10x. And 17 plus 8 equals 25. Our numerator now is x squared plus 10x plus 25. Then copy the common denominator, x squared minus 25. Are we finished yet? Okay, look carefully on our answer. We can check if they have a common factor to simplify our answer. X squared plus 10x plus 25 is a perfect square trinomial, having the factors x plus 5 times the quantity of x plus 5. And x squared minus 25 is an example of difference of two squares, having the factors x plus 5 and x minus 5. They have a common factor x plus 5, just simply cancel it. And for our final answer, the answer is x plus 5 over x minus 5. Did you have the same answer? Very good, grade 8 learners. What if the denominators are not the same? How are we going to add or subtract it? So don't worry, we have also method in adding or subtracting dissimilar rational algebraic expressions. Let us now proceed to the last part of our learning episode. In adding or subtracting dissimilar rational algebraic expressions, change the denominator into similar fraction using the least common denominator or LCD, and proceed as in adding or subtracting similar fractions, just like in your previous lessons on fractions. When adding or subtracting dissimilar fraction, you need to get the LCD of the denominators before performing the operation. Did you still remember how to get the LCD? Try to recall it with this example. Subtract 5 over 6 minus 2 over 5. Before we can subtract them, we must make the denominators the same. In order to do that, let us find their LCD. There are two ways to find their LCD. First, you can just simply multiply the denominators. 6 times 5 equals 30. Or the other one, find their LCM. List the multiples. For 5, we have 5, 10, 15, 20, 25, 30, and so on. 6 has multiples 6, 12, 18, 24, 30, 36, and so on. Then, find the least common multiple. And of course, that is 30. Now, that they have the same denominator, we can now subtract them by finding the equivalent fraction of 5 over 6 and 2 over 5, with 30 as the denominator. So simply divide the LCD to the denominator and multiply to the numerator, just like this one. The LCD is 30 divided by the denominator 6. Then, multiply by the numerator 5. And the answer is 25. We will do the same method in the other one. So 30 divided by 5 equals 6. Then multiply by 2 and the answer is 12. So finally, we can subtract them like similar fractions. So 25 minus 12 equals 13. So the fraction is already as simple as it can be. So the answer is 13 over 30. Now let us have an example in rational algebraic expression. For example number 1, determine the sum of 1 over 3a plus 1 over 4b. So first, we must make the denominators the same. Since 3a and 4b have no common factors, the LCM is simply their product. So 3a times 4b, the answer is 12ab. So rewrite the fraction using the LCD. So 12ab divided by the denominator 3a, multiply by the numerator 1, the answer is 4b. Next, 12ab divided by 4b, multiply by 1 is equal to 3a. Now, combine the terms, and we have 3a plus 4b over 12ab. The expression is already as simple as it can be, so that is the answer. Did you get it, grade 8 learners? Let's have another example. Try to answer this on your own. Just follow the steps carefully. Are you ready? Here we go. Subtract 2x over x squared minus 9 minus 1 over x minus 3. I'll give you 10 seconds to answer. Go! Time's up! Let's see if you got it right. Following the same steps, first, we must make the denominators the same. Since x squared minus 9 has factors x plus 3 and x minus 3, they have a common factor of x minus 3. So we don't need to write the 2x minus 3. Simply, the LCD is x plus 3 multiplied to the quantity of x minus 3. So let's continue by rewriting the fraction using the LCD. X plus 3 times the quantity of x minus 3 divided by x squared minus 9. Just cancel it. Then multiply to 2x, so we have 2x. Next, x plus 3 times the quantity of x minus 3 divided by x minus 3. Just simply cancel x minus 3. And the remaining is x plus 3. Multiply by 1 and we have x plus 3. Now, combined like terms. And we have 2x minus the quantity of x plus 3 over x plus 3 times the quantity of x minus 3. Now don't forget the minus sign. It changes the sign in every term of the numerator in the subtrahend. So 2x minus x is equal to x. Change the sign of 3 to negative 3. And we have x minus 3 over x plus 3 times the quantity of x minus 3. We can simplify this expression by cancelling out their common factor, x minus 3. Now, its simplest form is 1 over x plus 3. Did you get the same answer? Very good, grade 8 learners. Always remember the steps in performing operations on rational algebraic expression. To sum up everything that was previously stated, here are the steps in performing operations on rational algebraic expression. In multiplying rational algebraic expression, for step 1, express the numerators and denominators in factors. For step number 2, cancel out common factors. And for last step, simplify the expression if needed. In dividing rational algebraic expression, for step 1, get the reciprocal of the divisor. And don't forget to change the sign into multiply. For step number 2, get the common factors of numerators and denominators. And for step number 3, cancel out common factors. And last step, multiply the remaining factors in the numerators and multiply the remaining factors in the denominators, or simplify it. Division has the same steps as multiplication in performing operations on rational algebraic expression, except the first step, which is getting the reciprocal of the divisor. In adding and subtracting similar rational algebraic expression, for step 1, check the denominator if they are the same or not. For step number 2, if they are similar, just add or subtract the numerators and copy the common denominator. And for step number 3, simplify the expression if needed. And last one, in adding and subtracting dissimilar rational algebraic expression, for step 1, if they are dissimilar, make the denominators the same by getting the LCD of the denominators. For step number 2, rewrite the fraction using the LCD. For step number 3, just combine the terms. And for step number 4, if the expression is not written in simplest form, simplify the expression if needed. Again, congratulations grade 8 learners for another excellent performance. You did a great job today. Now that you are familiar with performing operations on rational algebraic expression, let us now check your progress by answering this activity. You can write your answer in your mathematics notebook. Here's the instruction. Perform the indicated operation and express your answer in the simplest form. For number 1, 10xy squared over 3mn multiplied by 6m squared n squared over 5x squared y squared. For number 2, a squared minus b squared over 2ab multiplied by a squared over a minus b. For number 3, 2a plus 2b over a squared plus ab divided by 4 over a. For number 4, x minus 1 over x plus 1 divided by 2x minus 2 over x squared plus 2x plus 1. For number 5, x plus 2 over 5x plus 10 plus x plus 2 over 5x plus 10. And last one, for number 6, 3 over x squared minus x minus 2 minus 2 over x squared minus 5x minus 6. That is all for now. I hope you learn and enjoy our lesson for today. And don't forget to send your answers to your respective math teacher. Again, this is Sir Joshua Q. Santos, your Mathematics 8 teacher. Until next time, have a nice day, be safe, and God bless us all.